And Mr. Myers.
We are super excited for Fun Science Friday. Today we're going to be investigating air.
Air and heat.
Yes.
And cooling.
And before we do that,
we just wanted to say, well, we had to get ready. And in order to get ready, we had to say a huge thanks to Tara Ellis for our awesome science gear. Thank you so much.
Okay, so like we said, we are going to be exploring air today and how it changes based on temperature.
Absolutely. So what we're going to need today is you're going to need a bottle. They recommend a larger 2-liter bottle. So if you have a big Pepsi or Coke bottle, they say that that would do better. This is all we have, so this is all we're going to use today. You need a balloon.
You need to make sure that you stretch out the balloon before you do the activity. So stretch out a little, blow it up.
Once or twice.
Yeah.
Get it nice and stretched out. That way it works a little better for you.
And then just put it over the top of your empty bottle.
Right. Don't blow any air into it or anything like that. Something else you're going to need. I think I said 2 bowls, but inside of your bowls, you're going to need hot water and you're going to need cold water. And the nice part about this experiment is you don't have to use the stove. So you can just get this straight from your sink. We put hot water in this bowl and we have regular water here, but then we also have ice cubes, which we're going to dump into there, and we're going to let that sit for a couple minutes to get really, really cold for us.
Okay, so first let's make some observations of our balloon.
Absolutely. So one thing for sure is that around the edge of the bottle, it is sealed. No air is getting in or getting out around the edge of the bottle.
Yeah, and it's completely deflated, so it's just like a flat piece of plastic here.
Flat piece of plastic, yep.
Now what we're going to do is place the bottle in the hot water.
Okay, so once we place in the hot water, we want to observe what the balloon is doing, and it might take a couple seconds. This isn't going to be an immediate response. Here we go. 3, 2, 1. Well, it's definitely blowing up.
Yeah, it's inflating.
Okay. I wonder if it's going to stand straight up.
I don't know. Oh.
What?
Gosh! There it goes.
No? Yes? It's kind of a stopping
Maybe. So they said if we had the bigger bottle, there would be a better chance that the balloon would completely inflate. So if you try this at home, you might see it actually stand up and completely inflate. Now we're going to move the bottle into the ice water and watch what happens.
I'm curious also, before we even do that, what would happen to the balloon when I take it out of the hot water?
Huh.
Is it going to lose air if I take it out of the hot water? What do you think?
I don't know.
All right, here we go. Interesting. So it kept the... Oh, nope, it is deflating a little bit. So let's go ahead and put it in the ice water. Oh, wow. It's like it's sucking out... Wow! It's sucking out all the air.
And you're not applying any pressure to the bottle.
I am not squeezing the bottle one bit.
Sitting there. Let's try again.
I wonder if we can go back. This is so cool.
Oh my gosh!
Now, obviously, over time,
up.
your hot water is
cooling
going...
down a
Yeah, it's
little
cooling
bit.
down.
Yeah.
So it's not going to be as easy.
And let's try moving it back again. Oh, it's still
I'm
blowing
gonna
up.
I'm going to let it blow up a little bit more. And then I'm going to move it over very fast this time.
Okay.
Ready?
Yeah.
Wow, that is so cool. I think it's cooler to watch it suck it out rather than to blow it up.
Yeah. Oh my gosh, it's just back to where it was when we first started, just that flat balloon.
Yeah, that is pretty incredible.
That's awesome!
Cool.
Okay, so let's talk about why that happened.
Absolutely.
So, inside of this bottle is air. Of course, we know air is all around us. And when we placed the bottle into the hot water, the air inside of the bottle heated up and therefore started expanding. So it needed more space. Oh, it's still doing it.
Yeah, it's still doing it.
It needed more space to move into. So it found that space inside of the empty balloon above it.
And so what happened whenever we cooled it is whenever those molecules start to cool down, they don't need as much space. I imagine kind of like the molecules are just settling down in the bottom of the bottle. They become more what we call dense, thicker. They go down and push together in the bottom. So because of that, they are actually creating a suction of the balloon. And if you watched our video from a couple weeks ago with the egg experiment, a lot of people were wondering, well, how come the egg got sucked down into the bottle? Same principle as this. When we put the match down into the glass bottle, it created heat and all those molecules were expanding and going up and out. But then as soon as the light went out, as soon as the heat went out and we put the egg on top, it started to cool very fast. And because it was cooling, it created a vacuum and a suction, which pulls all that air out and which pulled our egg down as well. In another experiment.
Wow. So air is pretty amazing.
Yes.
The way that we can change matter by heating and cooling it is pretty awesome. We hope that you try this at home, maybe with a 2-liter bottle. So send us some pictures. We want to see how big your balloon can get on top of your bottle.
Absolutely.
Awesome. Have a great weekend.
See you guys next week.